This is a question from IPM Indore 2023 QASA section. So this is a question from series. We are given a series where fn is sum of all the integers from 1 to n plus 1. Then there is another function gn which uses fn, right? And this symbol sigma means summation of all the values of 1 upon fn from 1 to n. So I will first explain this part. Gn is sigma k equal to 1 to k equal to n, 1 upon fk. So what does this mean essentially is you will write 1 upon f1 plus 1 upon f2 plus 1 upon f3 plus 1 upon f4 so on till we reach n, which is 1 upon fn. So that is the value of gn, right? So now how do we get the values of f1, f2, f3? We will get the values of f1, f2, f3 from here. So if I want to know f1, so f1 will be only the first number, f2 will be sum from, sorry, f1 will be sum from 1 to n plus 1. So it will be first two numbers. So f1 will be 3. f2 will be sum from 1 to n plus 1. So n here is 2, so sum will be till 3. So it will be 1, 2, and 3 sum. So that will be 6. So f1 will be 3, then next will be 6, then next will be 10, and so on. So that's how we can get the value of gn. Right? But that is not how we will solve this question. We will go back to this point, and from here we will simplify the steps. So I can rewrite this as k equal to 1 to k equal to n, 1 upon fk. Now if I look at this, what will be the value of fk? The value of fk from here will be 1 plus 2 plus 3 till k plus 1. Now that is sum of first n integers, and that is equal to k plus 1 into k plus 2 by 2. So that is the sum of first k plus 1 integers. So fk is this much. Right. So I can say gn will be 1 upon fk, and where fk is this much, k plus 1, k plus 2 by 2. And 2 comes here. So this is what gn is. K is from 1 to n. Now this gn, I can modify this gn again. I will write it here again. So gn is sigma k equal to 1 to n, 2 upon k plus 1, k plus 2. So I can take this 2 outside this sigma sign, and then it becomes 1 upon k plus 1 minus 1 upon k plus 2. So what I have done here is, if you have 1 upon 2 into 3, this can be written as 1 by 2 minus 1 by 3. The difference between these two numbers is 1, so you can write them as two separate fractions like this. So I have done the same thing here, right? So if I replace the values of k equal to 1 to k equal to n and then add them, so what do I get? So I can say gn will be 2 times 1 upon. I will replace k equal to 1 here and here. So that will be my first step. So 1 by 2 minus 1 by 3. Then k equal to 2, 1 by 3 minus 1 by 4. Then k equal to 3. Then k equal to 3 here and k equal to 4. 1 by 4 minus 1 by 5 and so on. So the last step, when I replace k equal to n, it will be 1 upon n plus 1 minus 1 upon n plus 2. Right. So as we can see in every step, the second term will get cancelled by the first term of the next step. Minus 1 by 4, the second term of second step will get cancelled by the first term of third step, and so on. Right. So I will be only left with the first term of first step and the last term of last step. So everything else will get cancelled. So Gn is 2 times 1 by 2 minus 1 upon n plus 2. This can be simplified. N plus 2 minus 2 upon 2 times n plus 2. So n upon n plus 2. So Gn is only this much. Now question says that this value should be more than 99 by 100. Now this should be more than 99 by 100. So what can be the value of n? 100n, that should be more than 99n plus 198. So n should be more than 198. So n is a value which should be more than 198. That means the minimum value of n can be 199. Anything more than 199 will keep Gn more than 99 by 100. So the minimum possible value of n, the least value of n, that can be 199. So that is the answer.